All right, Marek, are you ready?
Hi everyone, yes, I'm ready.
Awesome, then the stage is yours.
Hey all, I'm going to share my screen, if I may. So let's just go through all the milestones one by one. Okay, so my project name is Mac exclamation mark. This is the final milestone presentation for the ZKI3 cohort 3, and I'm Marek. So let's get started. This is where we left off last time after the midpoint demo. So let's just focus on what had to be done for the final milestones. So let's clear up what's already presented, and let's also add the milestones that have been discovered during this work. So there's few extra tasks. And let's just go one by one. So I will just show you and demo everything I did one thing at a time. So let's start with include random nonce field and pre-image to prevent pre-image attacks. So my ZK app, it has this export feature. So this is the live deployed one. So let's just go to export, and it can export the state of the app as a string. So this is, just as a reminder, this is how I avoid using any external storage or IPFS and all the things like this. Users can just share those strings, basically. And the thing is that the string has an encoded metadata, and for the original version of the app, I did not include any random nonce in this metadata, because I thought that since there is the ZK app address there, it gives enough entropy to make it impossible to guess what's the pre-image data given the hash itself. But later I added this feature that makes it possible to actually reuse the contract that has been already deployed. And then I realized that people could use same private key more than once, and then the address is actually not enough as a source of entropy to secure against the pre-image attack. So basically, this milestone is about adding some random values in the contract. So I updated the source. This is the pre-image data, and I updated all the tests and the data structure to include a random field in the metadata itself. It's the nonce field, and as long as it's random and new every time you create or reuse a contract, it's pretty much impossible to guess what the pre-image was given the hash. So this is the milestone E2, E for extra. Then include the missing unresolved outcome, preventing forever locked fans. So during the previous, the previous milestones for the midpoint demo, one of my milestones was about documenting everything, just because it's a pretty complicated app and I start to get lost in it. So I documented everything. And when I documented everything, I also reviewed the whole protocol. So the way the ZK app works is it has some predefined outcomes. For example, currently it's the warm-up stage. And based on in which outcome on chain the app is at the moment, yeah, it's the deposit stage, sorry. Yeah, next one is deposit, now is warm-up stage. So based on in which stage it is, it will allow different action from different parties of the contract. So now it doesn't allow anything, but based on the stage, like these buttons would light up and allow to do certain actions. And the bug I discovered during the midpoint part was that if nobody actually, if nobody judges success or failure, the funds will be locked forever. So it was pretty dangerous, because if you put some money in this contract and the person who is supposed to judge success or failure will forget to do it, it would prevent anyone to actually get back their money forever. It would just be stuck there. So this milestone was about fixing this bug and adding a new unresolved outcome. So it is there, I believe. Yeah, unresolved outcome. So basically, I had to add it everywhere in the serialization, and the tests, and later in the UI, but that will be another milestone, which I will show you later. So unresolved outcome is there, and now the contract is secured against locking the funds forever. Another thing is the protocol version and the format version. So that's another thing I discovered during the last during the midpoint part is I had the protocol version and the format version, and the purpose of that was to be able to have this thing evolve, because what if in the future we decide to do it maybe differently, or so basically the protocol version and the format version are single bytes which represent how this metadata should be interpreted, serialized, deserialized, and things like this. And the problem I discovered was that these values exist, but they were just predefined 0, and they were never part of this serialized string. So basically, the goal of this milestone was to update the serialization and deserialization to take those into account and include in the final serialized string, and also be able to deserialize it back. Sorry, that's the oral password. Don't worry, it's only for testnet. Where's my presentation? I keep accidentally clicking stop sharing because it's on the bottom of the screen. Okay, let's continue. Refactor the contract to use struct instead of circuit value class. So that's a surprise milestone. So the story is I was working on my milestones and getting stuff done. And then I realized that the Berkeley testnet is not working. So I thought, okay, then I will just use DevNet. When I attempted to use DevNet, it turns out that I can't because my O1.js version is too old. So I thought, okay, I will just update O1.js. But when I updated O1.js, turns out that almost nothing works anymore because there is no circuit value. So all these classes you see here, the values that are being used in the contract, they were basically extensions of the circuit value. So the solution for that was to update everything into struct. So yeah, Mate helped me a little bit, Gregor also, and I managed to do it. Although, yeah, that wasn't something I predicted to do. But yeah, every time there is update in O1.js, there is surprise work. So yeah, another milestone. Anyway, I updated the whole thing, and there's struct everywhere, and it still can be serialized and deserialized, and it's working. So it's done. Get rid of 11111. Okay, so that was a weird bug. Actually, every time I serialized the string, there was a long chain of ones here. And I thought it said bug. I thought I accidentally added some sort of, how to say, padding. I thought I added some padding. So I have 1 byte data, but I serialize it as 32 byte data or something like this. And that was clearly visible in the tests. So maybe I have an example here where it's visible. No, I think it actually prints it during the test. Let me just find, just to show you exactly what I mean. String preimage test. All the values are not random in this test. They are hard-coded just to avoid. Oh yeah, it console logs it. All right, never mind. But I will directly show you what's the reason behind it. So the reason for that was actually pretty stupid. The reason for that was, if you look at, oh, I actually updated it. So now the nonce, the random nonce, is some big value basically. But at the beginning for the test, I was just putting, I don't know, field from, I don't know, 5 or something like this. So if you take 32 bytes and the value is like 5, obviously there are only leading zeros for most of the byte representation of this value. And somehow, if you base 58 encode a string of zeros, it becomes a string of ones. So that was a surprise to me. I didn't know it's that, but basically it's something I spent a lot of time on, and it wasn't even a bug. Like, it was just putting some big value here and to ensure that all the bytes are being used and there are no leading zero and stuff like this. So anyway, I added as a milestone because it took significant resources from me. So yeah, that is done. UI adaptation to be compatible with updated contract and formatting. So basically here, it's everything I showed you previously was updates for the contract part of the app. But there's also the UI. So most of the time when I update the contract, it doesn't really affect the UI. For instance, adding the unresolved outcome did not require any UI changes, because if we just go to the interaction page, actually having the, having the unresolved outcome will not change how this page looks or acts. It will, like, the contract will just allow to do withdrawal after all the stages pass, basically. So it didn't really require any updates from the UI, but some other things did. Like, for instance, adding the random nonce. So I will show you how. Basically, if we decide to create a new contract, new ZK app. Hold on, let me just close the previous one, close the contract, and create a new one. So now in the deployment, you generate a new private key. It's blurred for privacy reasons. And also you can put this nonce value to protect from the pre-image attacks. And it also generates you a random nonce. So let's just copy. And this is one of the things I had to adapt. And is there something else? Oh, and also the formatting. So basically the formatting is this string had to take into account the protocol version and the format version. So I had to update the state of the app and store these values to be able to serialize and deserialize. So yeah, I had to update the UI, so I added it as a milestone just to adapt everything. So since we are at this stage, let's maybe just deploy a new contract. So let's just put some values here. My browser remembers it because I do it so many times in a row. I'm not going to comment much on what I'm doing because I did demo it many times. But for those of you who see it for the first time, I'm basically creating a new ZK app by filling out this form. And the values I put specify the rules on withdrawal and deposits. So here there are some human readable descriptions of those values. I just put A, B, C, D because why not? And let's just deploy. It's being proved now. And in the meantime, let's continue with our presentation. So that was the UI adaptation, fixed cache during the contract tests. So there was a bit of waste of resources here because what I did was every time I was running the tests, it was compiling the whole contract from scratch. So this milestone was about figuring out how to use caching during the test. So it was about adding this and using that in, oh, where is this? Here. It looks small, but it took me a lot of time to figure it out. And especially that I already had the compile cache directory because I am caching values for the UI just to speed up the compiling during from the UI. So I decided, why not also do it in the test to speed up tests? The performance improvement was insignificant, like almost no difference basically. And the reason for that is it turns out that most of the time during the test is being spent on the proving, because there are many scenarios to be covered. And every time a new scenario is being done, there is a proving part. I was thinking about disabling proving for that reason, because there's an option to disable it, but I'm not sure if it would actually test if the circuit works properly. So I haven't done that yet. That's something I have to discuss with probably Gregor or someone else who is more experienced. But anyway, the contract tests are being cached. During the tests, the contract compilation loads the verifier keys from the cache now. And another tricky part was actually for that to work, I had to run compile 3 times. If I run it once, it would create the cache values, but it would take no effect. If I run it twice, it would also create them, like from the previous ones, it would take no effect. It's starting from the 3rd time I run the compilation and writing in the cache that actually starts to take effect. And I don't understand why. I don't know why it's like that, but it's like that. So another milestone done. Let's carry on. The back contract interaction should indicate proving when proving is in progress. So actually, so I was thinking maybe this should show proving and blink, but then I realized that, hey, if this is already blinking and it's blocked, better not to change the value that is here, because that would confuse the user. Like you click deploy, and then it's like proving takes a lot of time, and you do something else in the meantime, and then you see that this button is proving, and you're like, what? I did not click on proving. What did I click on? So I decided not to change it. Instead, there is this little window that just showed up a few minutes before that was showing that now the contract is being proved. But the true reason why, oh, it loaded some keys from the cache. Proving works. So the true reason why I added this milestone, maybe I did not describe it properly, but it was not really about the UI. It was more about debugging the interaction itself, because during the previous cohort, I encountered some issues, like I was deploying contracts and interacting with them, and sometimes the UI would prove and create a transaction, broadcast the proof, and then the network would just reject this proof and the transaction would fail. And I could not understand why it happens. So, and I could not reproduce it since then, although I tried many times. Most likely the reason of that was that the method was not executed at the right time, because this smart contract allows execution of particular methods only within certain time frames described by the block numbers. And if you deploy a contract which has a very tight window for executing a method, then there is a chance that during the proving, the time window was still open, but, oh, it proved. So let's just broadcast the transaction. This is the transaction, deployment transaction, sign it, broadcast. Transaction is sent, and this is the Block Explorer link. It will take a few minutes to be confirmed. So anyway, what was I saying? It interrupted me. Yeah, so if the time window of the execution is too tight, there's a chance that during the proving, the window was still open, so the transaction was valid, so the proving worked. But when it was broadcasted and being confirmed by the network, the proof was no longer valid because the blockchain length changed and the window got closed. That's the only explanation I managed to come up with. But still, I declared I will do milestone like this, so I decided I should, like, even if I can't reproduce it, I should do something to prevent it. So I updated the UI. So now in the UI, you can see this. It's exactly what I wanted to show you. So it shows the current stage, and it shows you the next stage of the contract, and it shows you when you will be able to execute this action for the next stage. So, and you can change the unit, so you can have it in time estimates or also in blockchain length. So either like almost 24 hours, either 480 blocks, basically. This is more accurate. This is just an estimation. So if you have this, it basically prevents you from accidentally broadcasting a transaction that expired. And previous UI was not preventing that. So it would just, you would just wait for like a button to light up. Like you just click refresh, and you would wait for, oh, uncode promise error. Great, we got disconnected from DevNet GraphQL endpoint. So basically, you would just click refresh, and one of the buttons would light up, and you would just click, and it would prove and broadcast. But you would not know how much after, or like how much time you actually have left. Now with the current UI, you can see, like, if you see 10 seconds here, or I don't know, like 1 minute, you would probably figure out that if you prove it now, it will no longer be valid in, like, by the time the network starts to verify it and add to the block, and then your transaction will fail. So that's the only explanation I managed to come up with. Let's see if the transaction got confirmed. Still not. All right, so let's just continue with the talk. Yeah, and you can actually see that's something I already presented during the midpoint demo. So you can also see those estimates for each of the stages of the contract. And you can pick time estimates or blockchain length. So I reused the component I created during the previous part. All right. Yep. GraphQL still broken. I will tell you about another problem I discovered, but let's just go through all the milestones first. So contract interaction, debugged or not, I don't know. I think it is, because I added some mechanism to prevent that in the future. Layer of compatibility with wallets. So that was requested by Tomek from Palladians. We talked like 6 months ago or something, and we just saw a presentation he made about the Pallad wallet. So we will have Pallad wallet soon, and more wallets in the near future, hopefully. So what I did, let me just open a new window. I made this new UI here, console. So I always have to see the console just in case. So you can pick a network. Only DevNet is enabled for now. And you can also pick a wallet. So Pallad is already there in the list. But there's more, because it's not just the UI. Let's compile this. Basically, previously, Aura Wallet was so integrated in the UI code, like in the random places of the whole app, there would be some methods of interaction with Aura Wallet. So if we get a new wallet, such as Pallad, basically, to integrate it, you would have to update the whole code. So I decided to change it a little bit. I will show you what I did. If we go to my internet connection is not the fastest here, especially if the verifier keys are being loaded. Like each of them is like hundreds of megabytes or something. So if we go, you know what, I will just show you the local copy because why not? So there is, if we go to UI and components, there is wallets. Okay, no, still loading. I think it's really time to get a new computer. This is just a text editor and it hangs my computer. Oh, and maybe the GitHub loaded by now. All right, did or not? It's a race. Who's faster, GitHub or a text editor? Still compiling. Oh, come on. I just want to show some code, please. You know what? I will close that because it drains too much resources. Let's just go here directly. Yes. See, I stopped the compilation and it immediately started to work. Okay, so components. And now there is wallets here, here on the very end. So there is a wallet interface. So now if you want to add a new wallet to my app, you just need to extend the wallet interface. Like it has the basic methods that are required. And if you just put your wallet code in your implementation of the wallet interface, you can add a new wallet support. So this is what I did with Oro. So previously Oro was entangled in the whole app. Now it's just an implementation of the wallet interface. So there is get connected addresses, initialize, send transaction, etc., etc. And so it's like decoupled, you know. It's just one place. You update your wallet, you add it to the list, and that's it, you know. And I already started to implement it for Palad. So there's a Palad code here, but I'm sorry, I could not make it work. Like I tried, it was not doing what I expected, and I observed there were some problems if I had two wallets enabled. So for example, if I wanted to test Palad, I had to disable the Chrome extension, which was Oro, and vice versa. Like if I had Palad enabled, Oro was acting weird. So I did not manage to actually broadcast a transaction with Palad, but this milestone was about decoupling the code and create the wallet interface. So I did it, and now it's easy to add a new wallet. So it's done. And let me tell you about the last milestones. Actually, the 3 last milestones have been done in just one take. So I will just show you something. Let's see if that transaction passed. Yeah, it passed. So this is my ZK app transaction on DevNet. Passed. Everything's fine. Deployed a new ZK app. So let's go to the RFCs, because the last, let me just tell you about the last 3 milestones. So there is, my ZK app is very manual. So it requires people interacting. So it allows one party to deposit money, another party to withdraw it based on like what another party did, you know, something like this. And everything is judged by the users. So there has to be a dedicated user who will vote whether the contract was success or failure. And there were 3 limitations, so I added 3 milestones for it. One is the number of scenarios. Like currently there's just 2, like success and failure. And I wish there was unlimited number of scenarios. Limitation number 2 is number of parties that interact. Like now it's 3 parties. So person who judges, the arbiter, person who does the work, the contractor, and the person who hires the employer. So 3 parties fixed. I don't want that. I want unlimited number of parties. So that's the R4. And R5, it's about making bots, because the way it works now is just basically if you invoke a method in smart contract, it runs the check signature part. So there needs to be a wallet signing a transaction, and then the ZK app allows to judge success or failure. And it's hard to make a bot that would do it. Also, the contracts are by default human described. So it's basically just a string. And I want something that a machine can understand, so that people could interact, bots could interact, and also bots with people. So I wanted to research that. So I decided to write a new RFC. And I've written the provable outcomes RFC, this document. So basically, it solves all this. Unlimited outcomes, unlimited participants, and bots. And the way it works is, if you take a look at that, this is the whole contract state, basically. It's the whole ZK app serialized into a string. Based on that, you can deserialize the whole ZK app and deploy it again if you want. Like, it holds all the information, deadlines, the parties, the contract, everything. And I decided to change it a little bit and actually use ZK programs inside of it. So this RFC explains, sorry, not that, this. It explains how to do it with ZK programs. So unlimited outcomes is done using the Merkle arrays. So it's basically an array of hashes of the outcomes. Unlimited participants also. And also every outcome now is not like we have in this app, we have the outcome data structure. So now I call it a provable outcome. So apart from the just the description of the outcome, there is a verifier key there, or a hash of a verifier key, better. And if you provide a proof for this verifier key, resulting from a ZK program that makes the proof, you can make this contract withdraw money, for example, or confirm success or confirm failure. So basically, yeah, Merkle this, sorry. So basically, this allows to lift all the limitations. No more free outcomes. Now, unlimited number of outcomes will be possible. No more free participants. Now there will be unlimited amount of participants. And the participants no longer need to be people who read natural language. Now the participants could be just any bot that can run a ZK program and provide a proof that matches the verifier key. So thanks to these milestones, I finally had time to sit down and think about it. And I came up with that. And I think this is exactly what this app needs. And maybe in the future, I will implement it. But at least now we have a solution. I see we still have a few minutes. So I will just open these URLs before I take questions. I will make one more quick comment. So actually, I encountered one problem, which is very, very, very limiting. So I noticed that after I updated the O1.js to the most recent version, I think 1.1.0 or something like that, there is something super weird with the front-end build. So I was using the old O1.js version, 0 point something, like one of the last ones, 0 point something. Never had this problem. I was making a static build, deploying to my server. I was able to compile, load the verifier key cache, no problems at all. Now, like I make a build, I deploy, I can compile and, as I did now, I compiled it and proved and deployed a ZK app. but tomorrow it will stop working for some reason. I don't know why. Basically, once in a while, I have to delete all the files from the server, deploy the same build again, the same static build of the front end, and then magically starts to work again. I don't know why. I have no idea. So I'm wondering if anyone else encountered this problem. So yeah. Anyway, we have just 3 minutes left, I believe. So I will stop sharing and take your questions if you have any. Okay, I see some questions in the chat. Maybe I'll read them. Mahmoud says, how close is Mark from getting deployed on mainnet? So as now it works with DevNet, I could deploy it right now, and I'm pretty sure it would work. I'm just anxious about it because this is an app. This is an escrow app that is supposed to hold money and let it being withdrawn based on some conditions. So it could lead to huge potential losses from people. And it has never been audited. And also nobody ever really tried you need 3 parties to fully execute the whole protocol. So I did execute the whole protocol, but it was just me switching the wallets. So I think I would feel more secure deploying it to mainnet if there was really like a small community of people who, everyone sort of tried it and said it worked. Like otherwise, I'm pretty anxious someone will lose like thousands of mina because of me. Yes, Peter?
Hey, Marek. Yeah, kind of related to what you were just saying, actually. Do you have any plans is there like a kind of process you can go through to get some kind of audit? Do you think it's a big project to be audited?
All right. I think I would be confident enough to deploy it if there was like sort of a community audit. So let's say there is like, I don't know, at least 5 or 10 people, and we just played with this on my Discord server, tried it a few times. Everyone said, okay, it seemed to have worked. Then I just add a disclaimer, hey, you do it at your own responsibility. And then we deploy it to mainnet, and whatever happens, happens, Yes, exactly like this, Mahmoud. Yep, thank you, Yasin. Thank you, guys. I would really appreciate it. Any more questions, guys?
Awesome. Then, yeah, thanks a lot. It's great to see, all the community and our ecosystem players help each other. And I want to say thanks again to O1 Labs, Gar and the exploration team for joining, and I'm listening all the presentations. So shout out to them as well. Then I think we're good. Thanks again. It was a great presentation, Marek.
Thank you, guys.
Details and explaining all the milestones. I really appreciate it.
Thank you.
Okay, then we will continue with Kaupang, but let me